Okay, so the density of a gas was measured at 1.5 atm, 27 C, 1.95 grams per liter. We want to find the molar mass. Okay, so again, PV equals nRT. If I find my N, that should lead me to my molar mass. Okay, so N is PV over RT. P in this case is 1.5 atm. V is, I'm going to assume 1 liter, right? Grams per 1 liter. My R is 0.08206. My T is 27 plus 273, that's 300 K. Okay, so what I have, I'm going to clear this, and I get 1.5 divided by 0.08206 times 300, close my parentheses, and I get 0.0609 grams. I'm sorry, I get 0.0906 moles. Okay. So if I have 0.0609 grams, now molar mass is grams per mole, right? So if I take my grams, which I was given here, 1.95 grams, and I divide it by how many moles I have, divided by 0.0609 moles, I get 1.95, oops, divided by, and I'm just going to go up and pick up this number, divided by that number, equals 32 grams per mole. Okay, and I bet you can figure out what gas it is if it says it's a diatomic gas, and it would be oxygen, right? Alright, 1 mole mass of a gas. Alright, series of measurements are made to determine the molar mass of an unknown gas. This is actually a nice problem for stoic and everything else. Okay, just doing a bunch of stuff we've learned about. Okay. Alright, so a series of measurements are made to determine the molar mass of an unknown gas. First, the flask is evacuated and found to weigh this. It is then filled with a gas to a pressure of that many torrs, 31 degrees. It is reweighed, and this is its mass. So this tells us the mass of the gas. So let's figure out the mass of the gas. It's going to be 137.456 grams minus empty 0.567 grams. This is going to be let me see, 2.889 grams of gas. Okay. Alright. It is find the flask is filled with water at 31 degrees C and found to weigh 1067.9 grams. Okay, so and the density of water is this. So this is going to allow us to figure out the volume of the container. So what we know is the flask empty weighed this, and the flask filled all the way with water weighs this. And if we know the mass of the whole thing of water and the density, we can figure out the volume. So let's do that. So this is 1067.9 minus the flask empty, which is 134.567. And if I subtract those, I get 933.33 grams of water. And what I know from this density is there's 0.997 grams in 1 milliliters. Now I'm going to have to get this to liters, but let's just do this. I'll put one more factor there. It says 1,000 milliliters is 1 liter, and this is going to give us 0.9361 liters. Okay. So we know the mass of the gas, we know the volume, we know the pressure, we know the temperature. Okay, we want to know the molar mass. Okay, so we're going to do N equals PV over RT again. Pressure is 735 torr, so I'm just going to leave it at 735 divided by 760, right? That will give me ATM. Pressure times my volume is 0.9361 liters, and my R is 0.08206 liters atmospheres over moles K. This is atmospheres here. And my K is 31C. 31 and 273 is 304. That's 304. All of my units will cancel. Liters atmospheres. I'll be left with moles. And the number of moles will be, let's punch it. So 735 divided by 760, first to give me the atmospheres, times 0.9361 liters equals, I'm going to divide that by, in parentheses, 0.08206 times 304, close the parentheses, and I get 0.03629 moles, okay, of this gas. Okay, and I have this many grams, so again, let's do it up here. Molar mass is grams over moles. I have 2.889 grams. I have 0.03629 moles. So let's divide this. I'm going to get 2.889 divided by 0.03629 equals 79.7 grams per mole. Looks like that agrees with the answer. Okay.